Okay, this is question 9, slightly different compared to all the other questions, but we can still tackle it in a similar way. So we've got this kind of curved roof kind of construction. So we need to know the width of it. So if we take our ruler, measure it, it's 40 millimeters. But then we might have to break the shape down to try and work out the other dimensions. So we've got 5, 10, 15, 20, 25, 30, 35, 40, which is here. So we'll kickstart with that vertical line being projected upwards. And then it's the height of it. So we want the middle of the object. So if we just draw a little construction line in here, which is here, and then project that line upwards. So if we measure that perpendicular height of the object, which is 40 millimeters again. So again, we're going to go 5, 10, 15, 20, 25, 30, 35, 40, which is here. And then project that line across over here like that. Then we need to know when does this curve start. So what we need to do is we could kind of assume that I've made it easy for us. If we draw up 2 centimeters across here and 2 centimeters up on this bit, draw that line across. That's going to give you the radius here for this particular part, so this radius here. Now it's better to do it with a compass, which I don't have, so we'll have to do it by eye. So what we're going to do first of all is we're going to measure up 20, 5, 10, 15, 20, which is here. Just going to draw a construction line in, just project that across because I might need that later on. And I want the halfway points. We've got 5, 10, 15, 20, which is here. I'm just going to project that up just faintly to here. So between these 2 points here, preferably we'd need that's where your center would go. You'd need a compass and you would draw in the arc here on the side. So a 20 millimeter radius on a compass, that would give you this part here. So I'm just sketching this bit in because it's the kind of best I can do without a compass. So on here we would then measure what's that distance there. So this is 5, then the door goes up by 10 millimeters and it goes in by 5 as well. So in this bottom corner we come in by 5, up by 2 squares, 2 squares wide, and then if I draw my horizontal across and then fill in all the other details on here. So that gives us our front elevation of the object. Now what I'll try and do is I'll just go over that with a pen. Oops. Needs to be neater than that really, because we don't want any gaps on there that could cause some confusion. Now there is a floor section here on the drawing, so that means there's going to be a solid line going across underneath this part here. So if I draw that in, this bit's going to go vertically upwards here, and then we need a neat curve along the top here, preferably with no breaks in it. If I then draw in a vertical, and I've got another vertical here on the side over here, we can then tackle the plan elevation. So if I start the plan elevation 2 squares away from the top, I'll draw in my horizontal line across here, find out how far back this object goes, which is 4 centimeters. So we've got 5, 10, 15, 20, 25, 30, 35, 40. If I draw that section in, do my horizontal across, but I've also got some detail here which I need to project across. So the window, the door, whatever that might be, if I project that vertically upwards as well, and if we look on the drawing, it goes in by 5 millimeters here. So I need to go in by 5 and then come across here. Now, if I'm looking at the actual plan view, there's no detail on there, but I know it's there because I've just sent the information from the front view, which suggests that that door is going to carry hidden detail. So if we ink that bit in first on here, and the same on this part, if I ink that bit in there, so that means that this little door here would be dashed because I cannot see it from the plan view. Then we need the side elevation. So if I project that 45-degree line in again, so any horizontals here from the plan view, I send them across, it's going to hit that 45, send that across. I have actually got some horizontal detail there that needs to be projected across, and that's going to hit there. All of those points then need to be projected down, so it goes vertical, vertical, and another one which is vertical here. If I then ink everything in, so looking at the side view, the profile, it'll actually look like a square from the side view. So I've got a vertical line here, and I've also got a horizontal line here, and I've got a horizontal line here. Now, I've not sent all the information across here because a door needed to be projected across. So if I project that bit across here, that information that has come from the plan view and through has told me the depth of the door. Again, I cannot see it from the side view, so that means that this little door here would also be dashed as well. Now the only thing I've not put on here is something called a center line, which we discussed in one of the earlier videos on here about different types of lines. So this has got a curved surface here, so this bit is curved. So running through the center of here, we need a center line, which is a long dash, short dash, long dash, short dash, long dash, short dash, long dash. The same as what you get on the third angle orthographic symbol. Now we've got a curved surface here as well, which we can actually see from the front view, but what we're going to do is we're going to continue that center line down to the center point of that semicircle, and then across here we're going to draw a center line going across here. So start with the center, so we've got a small dash either side, long dash, short dash. So we've got a long dash here, short dash. Now here we can go, this is going to be a curve here, a curve point. So we're also going to continue that center line across onto the other drawing there. So if I was looking at this, if I didn't have this drawing here on the side, I can see there's a curved surface here on the front, but if I've only got this bit of information, the center line tells me that the surface is also curved.